So we've been looking at this paired data and mean difference on the paired data. And we did a simulation approach, and now we want to look at the theory. And really, there's nothing new when it comes to the theory because there really aren't two means, right? We have the data from one observation. In this case, we were looking at the drivers, and we paired between the old tire and the new tire. And so really, there wasn't an old tire and a new tire data. There was just the differences data. So really, the theory goes back to doing inference on a single mean. So if you recall, what the theory says on a single mean is that that distribution will be a t-distribution. And so this is the distribution of mean differences that you could get. And the validity conditions, if you recall, for a mean are that the sample size be at least 20 and sample not strongly skewed. Or if you happen to, or you can assume that the population is symmetric. So the population distribution is symmetric. So one or the other. You would have to have some knowledge of the population to claim that, maybe from past studies or whatever. So there's our validity conditions, at least 20. Again, no strong skewness, or you happen to know that the population distribution is symmetric. So when it comes to the applet, we're going to do exactly what we did for just a single set of data testing a mean. So let's check that out with our tire example. So here's the data we were looking at. We've got our differences here. So that's all we care about, right? We're just really doing statistics on these differences. So that's what I mean about this really isn't a two-mean situation. It's a single mean. We're interested in the significance of this one mean we got, the mean of the differences. So let's highlight those. And now I'm just going to go to my theory-based inference app for one mean. Paste my data. Clear out that data. OK, this is my old minus new. And notice it went ahead and computed the statistics for us. We could have actually, instead of copying the data, since I had already computed standard deviation and mean, we could have gone that route as well. But there it is as a dot plot. So let's go over here and test. Is this giving us significant cause for thinking that the mean difference is actually greater than 0? And remember, I used the little symbol mu with the subscripted d for mean difference. The app doesn't know that that's the context, so it's still just putting a mu there. But it's the same theory. And so it took our information and found what is the likelihood of being more extreme than what we had, and got a p-value of 0.0002. Super significant, right? That's less than 5%. That's less than 1%. That's less than 0.5%. That is very tiny, so very, very significant. So we're very confident that switching to the new tire on average will give better lap times for the drivers. And we could even do a confidence interval. So we can click on that and you can change the confidence level. So at a 95% confidence level, we would feel that drivers would on average improve their 10 lap time from somewhere between a half a second and 1.5 seconds. So we can get the confidence interval here as well. But I'm doing nothing different than what we did way back when we first did a single set of data and tested a mean, because there really is only one set of data. It's these differences, right? So it's just back to the one mean applet under theory based. The end.